Surface area and volume of spheres. A sphere is a three-dimensional geometric figure that is perfectly round like a ball. More formally, a sphere is a set of points in space equidistant from a fixed point called the center of the sphere. The distance from the center to any point on the sphere is called the radius of the sphere. Any point on the surface of a sphere is the same distance, the radius, from the center of the sphere. The intersection of a plane with a sphere is a circle. The circle C lies in both the plane Q and the sphere S. A plane that divides a sphere in half creates two hemispheres. This intersection reveals a great circle. The equator is an example of a great circle as it divides the Earth into northern and southern hemispheres. A cross-section is the intersection of a plane and a solid. The plane shown below divides the sphere in half into two hemispheres. Click the top hemisphere to see the cross-section. There we go. There is the cross-section. A plane through the center of a sphere intersects the sphere in a great circle. A plane that intersects the sphere but not through the center of the sphere is called a small circle. These are examples of great circles. These are examples of small circles. There is a great circle through the center of a sphere that is parallel to any small circle of the sphere. A segment H joining the centers of the great and small circles is a leg of a right triangle as shown. By the Pythagorean theorem, h squared plus r squared equals capital R squared, where h is the distance between the great circle and the small circle, and capital R and lowercase r are the radii of the great and small circles respectively. Here's an exercise. The radius of a sphere is 8. A cross-section 2 units from the center of the sphere is a small circle of the sphere. What is the radius of the small circle? So given that h equals 2 and capital R equals 8, find lowercase r, the radius of the small circle. So we have a right triangle here where this leg is 2 and the hypotenuse is 8. So 2 squared plus r squared equals 8 squared. 4 plus r squared equals 64. R squared equals 60, r equals the square root of 60, or 2 times the square root of 15. Here's another example. A cross-section of a sphere is 4 units away from the center of a sphere. The area of the cross-section is 16 pi units squared. What is the area of the great circle? Alright, so first we need to find capital R, the radius of the great circle. So we can use the Pythagorean theorem if we know the radius of the small circle. In order to solve that, we need to use the area. So we know that the area of the small circle is 16 pi. So pi r squared, which is the area, equals 16 pi. The pi's cancel. R squared equals 16, therefore r equals 4. Since this is a right triangle and both legs are 4, this is a 45, 45, 90 triangle, and we can see that r equals 4 times the square root of 2. You can also solve this using Pythagorean theorem, but this is the radius of the great circle. Alright, so here's the solution. The square root of 32 does equal 4 times the square root of 2, which is what we solved on the previous slide, but that is r squared. So we can use r squared to figure out the area of the great circle by plugging this value in for r. So we have area equals pi r squared. Area equals pi, and radius is 4 times the square root of 2 squared. So that equals pi times 16 times 2, which is 32 pi.